You're looking at our galaxy. At its center, there lies the most dangerous object in the Milky Way, a supermassive black hole called Sagittarius A-Star. For billions of years, this insatiable giant has been swallowing up everything that enters its gravitational field. But in 2014, the gas cloud G2 managed to escape this black hole, and that was quite a shock for scientists. How could G2 survive that fatal encounter? What will happen to a human if they get into a black hole? And most importantly, do we have a single chance of making it out of this thing alive? Why has this neat trick made the cloud so famous? In terms of astrophysics, all the odds were against G2, and it simply shouldn't have made it. A black hole's superpower is its ability to pull things and never let them go. Its boundary is called the event horizon. Everything that ever crosses this line, let it be an asteroid, photons, or even an imperial star destroyer, will stay inside the hole forever. When the cloud moved past Sagittarius A-Star, there were 40 billion kilometers between G2 and the event horizon. That's indeed a lot. For instance, there are roughly 6 billion kilometers between the Sun and Pluto. Can the gravity of a black hole catch an object from such a great distance? It depends on the mass and the size of a black hole. Sagittarius A-Star weighs as much as 4 million suns, and its diameter almost equals the minimum distance between the Sun and Mercury. If we imagine that a black hole is Magneto, G2 would be an iron coin located 1 kilometer away from him. Magneto could easily summon much larger things. As we see, the universe signed the cloud's death warrant. So, how did G2 outwit the laws of physics? The story began in 2006. A team of astronomers detected the gas cloud G2, situated 6,000 light-years away from us. It was 3 times heavier than Earth and was heading toward the center of the Milky Way. Calculations indicated that the black hole was supposed to pull the cloud and rip it apart in 8 years. But something went wrong. The pictures showed that G2 was approaching the hole at around 10 million kilometers per hour, but then it rounded the hole and started moving away from it at an even higher speed. Scientists called it space failure. Researchers soon noticed that as it was approaching Sagittarius A-Star, the cloud stretched out in its direction, but recovered to the original shape after leaving it behind. What's more, G2 was very hot, and this heat was stimulated from the inside. The answer was obvious. G2 is not a cloud, but a dense atmosphere of a star. That was the star's gravity that saved the cloud from being pulled to the black giant, and that restored its previous shape. Astrophysicists at the University of Cologne, Germany, have made a statement. According to their observations, G2 consists of not just 1, but 3 stars whose estimated age is 1 million years. As we see, the miracle that saved the gas cloud G2 was the fact that it isn't actually a cloud. But what will happen to a human being pulled by a hole? Will they survive this sort of adventure? Imagine you've approached the gravitational field of Sagittarius A-Star and took a leap into the unknown. The first thing you'll meet on your way will be an accretion disk composed of hot plasma revolving around the hole so fast that it almost reaches the speed of light. And here's the first trouble: ultraviolet rays, X-rays, and gamma rays, all of which can easily blind or roast you. During the first 10 minutes of your fall, you'll think that the black hole is drifting away and growing smaller. This effect is called optical aberration. After those first 10 minutes, you will move way faster and reach 4% the speed of light. You'll start catching up with the light ahead of you. Everything in front of your eyes will seem bright, while everything behind you will seem dark. This is the Doppler effect. In almost an hour, you'll enter the photon sphere. All the light it contains goes straight to the hole. In 24 seconds, you'll cross the event horizon. And at that moment, reality will be split into two. In the first one, the spacecraft passengers will find you dead. In the other reality, you'll find yourself inside the black hole, safe and sound. That's called Hawking's paradox. So, one of your versions is inside the black hole now. For the next 30 seconds, it'll be stretching your body with tremendous force. Then your remains will fall to a flat surface. You've arrived at your destination. This is the craziest ride in the entire universe. Can you finish it and stay alive? Here's a spoiler. You might. Let's rewind it a little bit, to that moment when you crossed the event horizon. What can be a way out of a black hole? Physicists allow that there are wormholes, or in other words, tunnels leading from one region of spacetime to another. A wormhole can connect a black hole with its opposite, a white hole. And if a black hole doesn't let you out, a white one doesn't let you in. That's like a vacuum cleaner working in reverse. But here you are, you've found a wormhole. To enter or not to enter? The answer is a definite yes. Falling into a black hole will lead to your death. Speaking of the other side of a wormhole, there might be our solar system, another dimension, or even the future. Who knows? In theory, you have a chance to escape a black hole alive. But can we actually check it? First, scientists need to send a probe to the nearest black hole and wait for it to find a way out. Given modern technologies, this experiment will take no less than 1,000 years. But what if the probe that we'll send there in the future has long gotten out of a white hole and has been giving us signals, and we just don't understand that? Perhaps we should pay closer attention to signals that seemingly don't make sense.